Okay, welcome to Chapter 9. We are now going to be talking about polar coordinates and polar equations, graphing, that sort of thing. So diving into lesson 9.1, we're going to put our focus right now on this triangle that's over here to the left. And some of you may notice I have my normal angle labeled as theta, and then I have two sides of my triangle, and this says to find the hypotenuse and the angle theta, which is this angle right here. Okay, so there's a couple things I could do. My first step would be probably to recognize that this is a Pythagorean triple. Okay, so the reason why in geometry they had you memorize those triples is because it makes life a little bit easier. So if it's a 3, 4, I know this one would be 5. I don't even have to think about it. Well, if you didn't know your triples, you are not dead in the water. So let's just go ahead and see what else we've got to do. We can use our Pythagorean theorem. Okay, so when we use our Pythagorean theorem, what we're going to do is basically a squared plus b squared equals c squared. So when I plug in these values, that becomes 3 squared plus 4 squared equals c squared. Now, it doesn't matter which order the 3 and the 4 go. Those are the two legs of the triangle as long as they go on one side and your hypotenuse goes on the other side. So now that I have this set up, that is equal to 9 plus 16. 9 plus 16 is 25. Remember that 25 is equal to c squared. So if I want to get to regular c, I'm going to have to put a square root on both sides, and my c is equal to a 5. So I can still get that same answer over here, even without knowing my Pythagorean triple. All right, the next piece that asks us to do, so we have that, we got our hypotenuse, right? We know that that's equal to 5. And then our angle theta. So back when we were doing our trig functions, we talked a little bit about how to find that angle. So if we knew 3 and 4, and the reason I'm picking 3 and 4 is because they're given, just in case I make a mistake with that 5, right? So 3 and 4 are given. This is the same as opposite. This is the same as adjacent with respect to this angle theta. So I look at what trig function has opposite and adjacent, and so to find theta, I know that the tangent of theta is going to equal opposite over adjacent, which is going to be 3 over 4. Well, I need to detach this theta from that tangent function. And the way I do that is to do an inverse function. So you should have had that in Algebra 2. So theta is equal to inverse tangent of 3 over 4. And when I put that in my calculator, I end up with a theta of, let's see here, 36.87 degrees. And I typically like to give 2 decimal places just to kind of make sure I have a somewhat accurate number. Could I say 37? Yeah, I could, but this shows that I actually did the math. Okay, so here we are. We figured out what our angle is, and we figured out what our hypotenuse is. And that's actually what polar coordinates are. It is stating what your hypotenuse is and what your angle is in a very simplistic form. And so let's go ahead and take a look at this. Unlike rectangular coordinates, xy, which is x comma y, that's considered rectangular. We've never had to call it that before because we've never had polar before. But now that we have polar, we're going to call that rectangular. So my rectangular coordinates, xy, my polar coordinates are going to be of the form r theta, where r is going to be the hypotenuse of the triangle that we just did, and this is going to be the angle. And it's that angle with respect to the positive x-axis, okay? So unlike rectangular coordinates, polar are of the form of r and angle theta. Well, let's go ahead and define a couple things. we just talked about what it represents, the hypotenuse and the angle. Let's look at these terms because we're going to be talking about these, and I just want to make sure that we're all on the same page. I'm going to write these down uh, with a alternating color, just like I did up here, just so you can see the difference between what I wrote. There's nothing special about the color. I'm just doing probably rotating between blue and red. So terms to know first, a pole on when we graph something like this is the equivalent of the origin. And when I say the origin, it is um, where everything, what we call anchors. We could also call it a pivot point. Once you get into physics and you start looking at rotational motion, you'll talk about torque, which is the rotational force needed to cause something to go into rotation. So that's really what our pole is. And let's look at what that looks like here. So that right there is our pole. It's just a dot. It's think of it like a hinge. So I'm going to put on here hinge, okay, like a door hinge. All right, so my polar axis is actually just going to be my x-axis. And this is where my angle originates from. So this is my polar axis. So this is where angle originates from. So you have to have essentially a base, like a home base of where you're starting. And then your ray or your terminal side, I'm going to go ahead and put this um, in green. This is going to be your ray or terminal side. And this is um, where the angle stops. And you can think about this as the hypotenuse. Okay, so when we were looking at the hypotenuse of a triangle, the thing is you got to be careful because a ray goes on. See where it has this arrow? It goes on for quite some time. When we're talking about a terminal side or doing the actual hypotenuse, we're going to cut it off at a certain point. So I might have a point P here, right, where you can make the equivalent of your triangle, and then this would be your theta, right? So then the last term that we really have got to make sure we know is angle, and this is the angle created between your polar axis and, sorry about my handwriting, your polar axis and terminal side. So we're looking at that difference. So in between from my terminal side to my polar axis, that's what my theta is going to be. Okay, that's my angle. I'll go ahead and put theta over here because that's usually what we call it. If we run out, we just continue to use other um, Greek symbols like phi. All right, so let's plot our first polar thing here. And so we've got plot 3 comma 60 degrees by first drawing. Oh, and I should probably put that this can be in radians or degrees. It doesn't matter which, but if you start with one, you have to keep going on that. By first drawing an angle of 60 degrees from the terminal side of this angle, draw well, let's go ahead and draw this first. So here's my pole. This is going to be my polar axis. That's my x-axis. And then I'm going to go about 60 degrees. That's about like this. So this will be my terminal side. Okay, so this is my angle 60 degrees. So I've got that set. And then I have this number 3. It's going to be 3 units that I'm going to mark out. And I'm going to draw a number line. Okay, This is a real number line. I'm not dealing with imaginary numbers at this point. We just don't want to go there. So I have a real number line that I'm doing, and I'll put that in red. And so I might have one unit here, and this would be my third unit. So this would be 3 comma 60 degrees. And remember, this is my ray, or my, I shouldn't really call it a ray. This is the magnitude of this polar function, and then this would be the degrees, okay, or the angle. So it's my hypotenuse and my angle. And I could actually make this into a triangle. If this were my unit circle, I could actually figure out what those coordinates are and then multiply it by 3. So all kinds of things I could do with that. Okay, so that's plotting one. We already talked about this. Angles can be measured in either degrees or radians. Okay, degrees or radians. In addition, the value of r can be positive or negative. If the r value is negative, describe how it affects the drawing of the point. Well, let's show you how to do it first. So let's look at one that's negative. So we have -3 and 60. We've already done 3 and 60. So what I'm going to do is start with that. So I have 60 degrees because that's what it has on my angle. Okay, so 60 degrees. If I have my 3, right? So 1, 2, 3. So this is 3 comma 60 degrees. When you have a negative in front of an r value, it just means it's going the opposite direction. So I'm going to carry this back this way, and I'm going to mark out 1, 2, 3, and that would be -360. Okay, so let's go ahead and describe what we just did, because once we get into words, that will help us. So describe how this affects the drawing of the point. Let's write if r is negative, draw the opposite direction, and I'm going to put ray down just to kind of let you know that we're going the opposite direction. And go r in absolute value units on that new ray. So that's what we did here, right? We took 3 and 60, which I already knew, and instead of going this direction with it, we took it back the opposite way. So that negative puts it in the opposite direction. So if this is quadrant 1, this one is quadrant 3. Okay? So if I had one that was going this direction, then the negative would be going this direction. So it's just, it mirrors exactly across the origin what you have. Okay? So that's what we've got. All right, what are the rectilinear coordinates of this point? Oh, we haven't talked about that, right? We knew that this one, did we find the rectilinear ones of this? We did not. You know what? I think what we'll do is once we flip over to the next page, we're going to learn how to do rectangular coordinates from a polar, and we'll come back to this page, okay? For now, what I want you guys to do is that I want you to go ahead and practice plotting the following points. So 3 comma 5 pi over 3, 2 comma negative pi over 4, 3 comma 0, and -2 pi over 4. So I want you to know how to plot all of those points and draw them. You're just going to go ahead and draw your own coordinate lines underneath here. I don't know how big you need them, so you're going to go ahead and draw them. I'm going to go ahead and stop the video here. The next video will go over these questions.